This screencast will show you how to get phase notations from solubility rules. On the periodic table that you received on the back side, there are several reference materials. The reference material that we're going to be looking at today are the solubility rules. So you will always have this reference, you just need to know how to use it. So this is going to go with the worksheet that you should have already received on using solubility rules, so please have that and this periodic table available. Pause if you need to get these materials. So what you're going to see on this worksheet is that the solubility of a solid compound in water can be predicted by general solubility rules that are listed on this reference sheet. Again, this is the back side of your periodic table. Okay. And this is going to be used for double replacement and single replacement reactions. So the same rules are still going to apply for synthesis and decomposition that I taught you before, but this is going to be how you get phase notations for ionic compounds in single and double replacement. So again, just a review, if a substance is insoluble, a solid does not dissolve in water, and its phase notation will be S. So if a substance is soluble, the solid dissolves in water, its phase notation is AQ for aqueous or solution. So the real key thing is to remember that S stands for solid and not soluble. So soluble is AQ or solution. Solubility rules are listed based on the anion in the compound, and anion is a negative ion. You should already know that. This should just be review. So when you're determining solubility, you need to determine the name of the second part of the compound. So again, for this one, we have Cl, which is chloride. It's the second part of the compound. You're going to scan your rules until you find the chloride rule. So chlorides are soluble except for those of silver, mercury, and lead. So we have sodium. Sodium's not an exception. So the compound sodium chloride would be labeled AQ in a single or double replacement. For zinc hydroxide, the parentheses tell you that OH is a group, so you're going to come to rule number 6, which is the hydroxide rule. You might want to do what I'm doing with the highlighter or underline the group names just so it makes them pop out a little bit easier for you. So rule number 6 is our rule. They're insoluble except for those of the alkali metals, and we need to define alkali metals, so this is going to be group 1A on the periodic table. Okay, and there's also a place down here to write that. So 1A is your alkali or alkaline metals, just depends which term is used. Okay. For the next example, you have 3 elements and no parentheses, but I'm hopeful at this point you can identify sulfate as a group, and once you do that, you're going to find your rule for sulfates. So sulfates are rule number 2. They're all soluble except silver sulfate. So since silver sulfate is an exception, you're going to have that labeled as an S, since it's the opposite. Okay, the next example, PbBr2. You're not going to see Br2 listed anywhere, but if you remember crisscross rule, bromides are going to come from the element being by itself with no oxygen. So we'll be looking at bromides up here. They're soluble except for lead. So since lead is an exception, this one is also going to be labeled as solids. And this is a process you're going to use for all your formulas. I just want to point out a couple other things that will be important to you. So rules 4 and 5 are listed by alkali metal salts and ammonium salts. So salts are just a fancy name for ionic compounds, okay, that aren't acids or bases. And again, alkali metals we referred to down here. Rule number 5, your acids are soluble. So again, you should be able to recognize an acid as a compound that starts with hydrogen. And then finally, the last thing you need to know down here in the bottom, alkali earth or alkaline earth metals is group 2A. And this rule shows up in, this shows up in rule number 7. If you have a sulfide, you need to know that the alkaline earth metals, okay, are also soluble as sulfides. So magnesium sulfide, beryllium sulfide, calcium sulfide, strontium sulfide, barium sulfide, radium sulfide would all be aqueous. Okay, at this point, I'd like you to flip to the back of the worksheet that has your solubility rules and fill in the information at the top. Remember, soluble is AQ, insoluble is solid. The exceptions just switch them. So something that's normally aqueous becomes solid. Something that's normally solid becomes aqueous.